By the end of this lecture, learners will be able to explore the importance of logical reasoning skills to achieve academic success. Identify types of logical reasoning used to improve learners' study routines and outcomes. Assess how these approaches are applied in educational settings and their influence on learning quality. Evaluate the impact of logical reasoning methods on increasing student motivation and participation. Hello everyone, and welcome. In this lecture, we will explore various types of logical reasoning that are crucial in supporting students' academic success. We aim to understand how they are practically applied in modern educational settings to enhance learning outcomes. The discussion will highlight the unique strengths and differences among these logical strategies, providing clear examples of their use. Also, it seeks to offer deeper insight into how logical reasoning helps reveal the effective habits and approaches of high-achieving students, contributing to improved academic performance. So, let's begin with this question. How do logical reasoning skills influence a student's ability to understand and analyze complex information? Logical reasoning is the backbone of critical thinking, empowering individuals to handle complex problems and make sound decisions. It involves the ability to analyze arguments, identify patterns, and draw conclusions based on evidence rather than emotion or assumption. Mastering logical reasoning fundamentals enhances one's problem-solving skills and develops a mindset that values clarity and coherence in communication. Whether in academic endeavor, professional environments, or everyday life, honing these skills enables us to dissect intricate issues, challenge biases, and arrive at well-founded conclusions. Exploring the principles of logical reasoning equips us with essential tools to engage assertively with the world, significantly enhancing our understanding of the complex ideas that shape our reality. Types of reasoning. Reasoning is a cognitive process that can take various forms: deductive, inductive, abductive, each with its unique approach to understanding the world. Each type of reasoning serves a distinct purpose, enriching our critical thinking skills and enhancing our ability to deal with complex decisions in everyday life situations. By understanding and mastering these various reasoning styles, we empower ourselves to think more clearly, argue more persuasively, and embrace the nuances of the world around us. Reasoning comes in several forms, each with its unique functions. Deductive reasoning. Deductive reasoning represents a fundamental logical approach where conclusions are systematically derived from general premises to specific instances. In this method of thinking, individuals start with a broad, established principle and progressively narrow down to a precise, logical conclusion. For example, if one knows that all mammals are warm-blooded, general premise, and understands that dogs are mammals, specific instance, they can confidently conclude that dogs are warm-blooded. This reasoning pattern is crucial in various disciplines, including mathematics, philosophy, and scientific research, as it allows scholars and researchers to develop reliable, structured arguments by systematically applying universal principles to particular cases. Unlike inductive reasoning, which builds general conclusions from specific observations, deductive reasoning moves from the general to the specific, offering a rigorous and transparent path of logical inference. Inductive reasoning. Inductive reasoning is a powerful cognitive method that enables individuals to develop broader generalizations and theories based on specific observations and empirical evidence. Unlike deductive reasoning, which moves from general principles to specific conclusions, inductive reasoning follows the opposite trajectory, constructing comprehensive understanding from particular instances. Scientists, researchers, and critical thinkers frequently employ this approach to generate hypotheses and develop theoretical frameworks. For instance, after observing multiple instances of a particular phenomenon, researchers can formulate a general principle or predictive model. A classic example might involve studying multiple swan populations and concluding that all swans are white, based on accumulated observations. However, inductive reasoning acknowledges its inherent limitations, recognizing that conclusions are probabilistic rather than absolute and remain open to potential revision with new evidence. This flexible and dynamic reasoning approach is fundamental to scientific inquiry, enabling researchers to explore complex patterns, identify underlying principles, and advance knowledge across various disciplines by systematically analyzing and synthesizing specific empirical data. Abductive reasoning. Abductive reasoning is a unique form of logical inference that focuses on generating the most likely explanations for a set of observations, making it particularly valuable in fields such as science, medicine, and detective work. Unlike deductive reasoning, which guarantees conclusions based on established premises, or inductive reasoning, which builds generalizations from specific instances, abductive reasoning seeks to identify the best possible explanation for incomplete or ambiguous information. For example, a doctor observing a patient with a persistent cough and fever might consider various diagnoses, but ultimately, they would select the most plausible explanation, such as a respiratory infection, based on the symptoms presented. This reasoning process allows for creative problem-solving and hypothesis generation, as it encourages individuals to consider multiple possibilities and select the one that best fits the available evidence. Abductive reasoning is essential in situations where certainty is unattainable, enabling researchers and practitioners to make informed decisions and advance understanding in complex and uncertain contexts. The practical combination. In practice, human reasoning is a sophisticated and dynamic process that seamlessly integrates inductive, deductive, and abductive reasoning to cope with complex intellectual challenges. Scientists and researchers exemplify this integrative approach by employing a multifaceted reasoning strategy that leverages the unique strengths of each reasoning type. Initially, they might use 1. Inductive reasoning to identify patterns and generate hypotheses by observing specific phenomena, systematically collecting and analyzing empirical data. 2. Deductive reasoning to rigorously test these hypotheses, constructing logical frameworks that systematically evaluate potential outcomes and validate theoretical predictions. 3. Abductive reasoning to explain unexpected results, enabling researchers to creatively propose the most plausible explanations that bridge observed phenomena with existing knowledge. This holistic reasoning approach transcends academic research, reflecting how individuals naturally process information and solve problems in everyday life. By dynamically combining these reasoning methods, we can develop a more nuanced understanding, generate innovative solutions, and expand our comprehension of the intricate world around us. The synergy between inductive, deductive, and abductive reasoning represents a powerful cognitive strategy that drives intellectual progress and critical thinking across diverse domains of human experience. Comprehensive integration. The interconnected nature of logical reasoning provides a powerful framework for intellectual exploration. By integrating precise logical structure, rigorous validity criteria, diverse syllogistic approaches, critical thinking skills, and practical applications, scholars can develop more sophisticated analytical capabilities. This holistic approach enables researchers to 1. Challenge existing intellectual paradigms. Challenging existing intellectual paradigms is a fundamental aspect of scholarly inquiry that propels the advancement of knowledge. By questioning established beliefs and conventional wisdom, researchers can uncover limitations within prevailing frameworks and inspire fresh perspectives. This critical examination stimulates intellectual debate and encourages a culture of skepticism that is vital for growth in any academic discipline. 2. Generate innovative theoretical insights. Generating innovative theoretical insights requires a blend of creativity and rigorous analysis. Scholars who engage deeply with their subjects often find themselves at the intersection of established theories and emerging trends, allowing them to synthesize information in new ways. This process of innovation involves the introduction of new concepts and the reimagining of existing ones, leading to theories that challenge traditional boundaries and expand our understanding of complex issues. 3. Communicate complex ideas more effectively. Effective communication of complex ideas is crucial in academia, as it ensures that valuable insights reach a broader audience. Scholars who master the art of clear and concise expression can distill intricate concepts into understandable terms, making their work accessible to both specialists and non-specialists alike. This ability enhances engagement with their research and facilitates collaboration across disciplines. When complex ideas are communicated effectively, they resonate more deeply, inspiring others to contribute to discussions and applications that can lead to significant advancements. 4. Promote interdisciplinary understanding. Promoting interdisciplinary understanding is essential in today's interconnected world, where challenges often transcend traditional academic boundaries. By incorporating collaboration among diverse fields, scholars can leverage varied perspectives and methodologies to tackle complex problems more holistically. This interdisciplinary approach encourages dialogue between disciplines, enriching research with insights that might otherwise remain isolated. As scholars engage across fields, they broaden their understanding and develop a shared intellectual landscape that enhances innovation and drives collective progress in addressing pressing global issues. The ultimate goal of logical reasoning transcends mere technical analysis, offering a transformative approach to understanding and interpreting the complex intellectual landscapes of contemporary academic discourse.